Yo guys, this is Mohammed Fahan. Today I'm back with a new video about the Earth magnetism. So it is quite interesting topic, and I hope, and I can say, I can bet that after viewing this video up till the end, you will get the better knowledge, better information about the Earth magnetism, and almost all the doubts. I think may be clear by the end of this video. So let's start. It is just like that. Earth magnetism, as I mentioned here. So earth magnetism, here comes the earth magnetism. So we can understand the earth magnetism by the three terms: angle of declination, second angle of dip, and third and the last one, horizontal component. So this is just like this. So firstly let us understand the angle of the declination. तो angle of declination is generally अल्फा से डिनोट करते हैं, तो इसको हम जनरली फाई से डिनोट करते हैं. So angle of the declination. So angle of declination, for just we understand before this we need to understand about something about the earth magnetism. Say this is the earth, and we know that earth's north pole and the south pole are just like here it is north and here it is south, and the direction of the earth magnetism is just like this, and in actual this side is south, magnetic south is along the north side of the geographical earth axis, and this is the north, just opposite, and the angle between them is 11.5, which is fixed angle. So here what we have to notice is that this angle, which is the angle, actually this is not a line. If you will I will make it in quite 3D. If you can notice here that here we have earth. So if I try to make it a 3D look, so it is just like this. So here it is just like that, if you can feel the depth. So here if you can notice, the earth is not just like the plane, it's just quite 3D, and here the line would not gonna do work. So we have to take a plane. Just if we take a plane inside the earth, yeah, you can notice now the depth and take the feel about it. It is just like the plane, it is the north and it is south. It is geographical meridian. This plane is called geographical meridian, and the plane which is here, actually this plane, it is called magnetic meridian. And here what we have to know about that, magnetic meridian and geographical meridian are the two important terms which are need to be understood before going through the angle of declination. So here angle of declination is nothing but the angle which the magnetic meridian and the geographical meridian made with itself. So this could be better understood by the example setup I have made here. So this is our book. So here as you can notice, this side, let us say this tile to be our geographical meridian I have mentioned, and this one to be magnetic meridian. Okay, so what is our angle of the declination? It could be better understanding by looking this book. So here it is three diagrams. So it is representing the geographical meridian and this representing the magnetic meridian. So these two are lying in the same plane, but here you can notice it can't be that much clear, but here it is quite clear. So if you will notice from the upper view, so this angle, the angle which the geometric meridian and the magnetic meridian made with each other, so this angle is the angle of the declination. So what is the angle of the declination? The angle with the geographical meridian and the magnetic meridian made with itself, that is alpha. So this is the angle of the declination. So I thought this is quite clear to all of you that what is the angle of the declination. So now let's move to our next topic, that is the angle of the dip. Angle of dip. So angle of dip is nothing, but it could be better understand by taking an example. So let's say this is our magnet which I have suspended by a rope. So let's say it is, I have mentioned here the south and the north, both sides. So if you will suspend it, so what will happen that initially the it will suspend itself in the direction of the magnetic north and the south. So here it is, say it is quite say after being suspended it is free, it is now in the stable position. So now what will happen, as you can see, it is not actually quite horizontal, it's actually somewhat tilted. So this tiltedness is nothing but our angle of the dip. So angle of dip is what? So our angle of dip is nothing but the angle but the angle which the resultant made with the horizontal component. So this could be better understand. Say this is our book, exam idea hai this. So here this is the magnetic meridian upper side. So the angle which by which our magnet by tilt down, so this angle is phi, is what? Angle of dip. Angle of dip is what? By which a magnet gets tilted down. So this is the angle of the dip, and angle of the dip which is generally asked in our examination is that when we have the magnet like this. So if we notice the magnetic field always travel from the north to south side, so they will not being going to be, sorry, they are not actually going to be collide each other. Let me make it again. So this is our magnet. So this is our magnet, ये south थी and this is north. So magnetic line will gonna be like this, so they will travel just like this. So here, as you will notice in the direction, as you can notice, so here it is just like this. This is horizontal and this is the resultant magnetic field. So here the angle of dip is 90 degree, that is phi. And what you will notice here, the horizontal line is this and this is the resultant magnetic field. They both are parallel to each other. So what is the angle here? The phi is equal to 0 degree. So this is generally asked and this is how it comes. So this is, I think, all over. And horizontal component. Okay, so now comes the horizontal component. As I told you, horizontal component, angle of dip is actually the angle which the resultant made with the magnetic meridian upper side. So this is what the angle of the dip. So as you can see, this is phi, and say this is the resultant. We say the resultant as B. So if we break in its straight rectangular component, so here it is B. So what will going to be in this direction? This could be B cos phi, and in that direction B sin phi. So B cos phi, as you all know, is the horizontal component. So this is nothing but the horizontal component, that is B cos phi. B cos phi. This could be now better understood, as I have already make you understand about with the help of the book. So now what will happen, it just could be easily understand with the help of the diagram here. So here it is, just like the book being opened, and this is our alpha, and this is by which the magnets get tilted is angle of dip phi. And here it is say B, this is the uh, resultant direction, so it will be B cos phi, and this is B sin phi. So B cos phi is what? The horizontal component which we are looking for. This is the horizontal component.